So good afternoon, good morning, good evening. Thank you all to join us today for another Industrial Talk 2021. As you can see, this series of Industrial Talks are sponsored by IEEE Secrets and Systems Society, Chapter Rio Grande do Sul, Solid State Secret Society and Electron Device Society, Chapter Rio Grande do Sul, and Council on EDA, Chapter Brazil. So today we have the pleasure here to have Cleber Figueira, Research and Development Director from Smart Modular Technology, that will give an overview of Smart Brazil. But before giving the floor to him, just some few announcements. So next Friday, we have the last CAS talk of the season 2021 with Roberta Burger from Infineon, Germany. So she's going to talk about challenge in pre-silicon verification of analog mixed signal automotive products. So I'm sure that you are going to like this last talk of this season. Then on December 13, 14, put in your agenda the YCAS, so the workshop on women in sequencing systems. And then the IEEE CAS meeting of Chapter Rio Grande do Sul. So soon you are going to see a little bit more about the program. And if you lost any CAS talk in 2020, 2021, as well the industrial talks, you can find these talks and much more in this YouTube channel of CAS Rio Grande do Sul chapter. There is more than 100 talks available in this YouTube channel. So today we are here to listen to the talk by Cleber Figueira. So Cleber Figueira, actual position is Research and Development Director at Smart Modular Technology in Brazil, responsible to explore the benefits provided by federal government in this area using informatics law, PADIS, and innovation law. He has more than 20 years of experience on research and development area, starting his career at Daruma Telecommunications, LG Electronics, Ericsson Telecommunication, Flextronics, and Smart Modular Technology in Brazil. Nowadays, he is doing a master's degree in administration strategy area at FIA Business School. So thank you very much, Cleber, to accept our invitation to give this overview of Smart Brazil today. So now I'm including your slides. So now the floor is with you to start your talk.
Okay, thank you, Professor Ricardo, for the invitation. It's a pleasure for me to be here today to share about some information about smart technology structure in Brazil. So I prepared a short presentation. So let me move ahead here. So this is the contents that I prepared to share with all of you. So the main idea is to give you one introduction about the Smart Global Holdings. So the group that is responsible for the Smart, where Smart Brazil is included. So also I'd like to talk about the structure that we have inside in Brazil. Then I'd like to get in deep about some product portfolios, the products that we have, what we are doing in Brazil nowadays, and the IoT actions that we are under developing nowadays with our local team, the research and development team that we have in Brazil. So let's start, let's move ahead. So just to give you one overview about Smart Global Hold. So Smart is founded in 1998. So our headquarters is located in Newark, in California, USA. So we have around 4,000 employees, and we have several companies around the world, as we can see the footprint. So we have companies located in California, in Fremont. Also, we have a manufacturing area in Malaysia. So also we have in Brazil almost 3 three structure for manufacturing process in Brazil. Basically, Smart has three different business lines. So the first of them is the intelligence platform solution groups. So where we have three main companies that is split in Penguin Computing is one of the companies from the group, embedded computing and wireless computing. So this group, their main activities is a focus on high performance computing, high reliable embedded computing platforms. So this group has a very close relationship with Qualcomm to develop Snapdragon platforms. Also, we have another business line that is smart memory solution groups. So this group is the global leader in specialty products, include memory modules, solid state drives, hybrid solutions, and so on. This is the position where Smart Brazil is located. So our team is under the memory solution group inside of the Smart Global Holds. And the third group that we have is the newest company that Smart acquired in the market almost 2 years ago is the CRELAD. So the CRELAD is the most famous LED manufacturer in the world. So they are focused in applications such as high power general lighting, automotive video screen. So this is a very important acquisition that Smart Global Holds did to support the activities from the entire group. So at the next slide, I will start to talk about Smart Brazil a little bit. So basically, Smart Brazil has three manufacturing companies in Brazil. We have two of them is located in Atibaia, São Paulo state, where we have one advanced IC package line, where we are developing the memory modules, the memory integrated circuits, and also the memory modules. And recently we announced another manufacturing company located in Manaus. We just started our production there. We started in September 2021, right? Also, we have a very good relationship with Eldorado Institution in Campinas. We develop one advanced package laboratory inside of their structure where we are using nowadays to develop our new products and the new technology that we are looking for the future. Also, we have a very important group located in Korea. So this is a group dedicated for our activities in Brazil. So they are located in Korea based on a strategic definition that we did, because this group they can work very close with the most important semiconductor companies in the world. So such as Samsung, Hynix, Hana Micro. So we have the opportunity to be very close with them, looking for the new technology and also the trend technology that we have on this important area for the world and also for Brazil. Moving ahead. Oops. So just to give you one overview about the activities, the timeline from Smart in Brazil. So in this year, Smart is completing 20 years as a package IC support in Brazil. We can consider that we are the market leader in semiconductor technology in Brazil. In the top side of this slide, I'm showing the main marks that we had during the Smart history since 2002. So in this part, we started our activity when Smart acquired the NEC Brazil Memory Division so that we had in Guarulhos, São Paulo. And since of that, we started to develop all the activities in Brazil. The most important and the most relevant items that I would like to share with all of you is about in 2011, when we split the company in two legal entities. This is the year that we start to work with informatic law and also PADIs in Brazil. And this is the year that we divide the companies based on especially because on one of the necessity from the PADIs regulation. Right. So in 2016, we concluded the activities with Eldorado. Once we announced the R&D package line and test line inside of the Eldorado. And now 2021 is the new factory that is located in Manaus, Amazonas, with more than 5,000 square meters. In the bottom side of the slide, I'm showing the most relevant products that is launched in the Brazilian market. So we started our activities in 2002. So we started with GRAM module, right? And we are move ahead developing with the other products. So the most relevant activities that we have nowadays, we can say that 2013 and 2016 is the most important period from Smart, where we launched our memory devices in the market. So we started to work with the smartphone companies in Brazil. 2020 is a new business area that Smart started to work. We started to develop some IoT devices in Brazil, and 2020 is the first moment that we launch our model in the market. So in 2021, we'd like to put some emphasis in the SSD. We are backing to manufacture the SSD in Brazil again after almost 10 years. So we decided to stop this area in 2011, and now we are backing to support the market necessity. And now we are moving ahead with the new technology. Is one evolution from the MMC and the MCP that we call the UMCP and also UFS devices. So here, just to give you one overview about the Smart Brazil factories. So we have the semiconductor company located in Atibaia. We have the capacity around 150 million dies per year. This is our actual capacity that we can assemble. We have around 15,000 square meters. And from this 15,000, 5,000 is a clean room. And our major activities is a packaging device, integrated circuits in the several areas that I already explained in the previous slide that have DRAM, Flash IC, and SSDs and others. Right? For our memory companies, as I said, we have two structures, one in Atibaia and another one in Manaus. And also we have the R&D center inside of Eldorado Institution in Campinas. So our internal capability, our production capability, all the machines that we have in our production has M2M communication. All of them is based on the Industrial 4.0. And also we have a full automation system. We have more than 316 robots in the structure that we can help and make our production easier. And also to support our entire system, our entire production line, we have a specific mess that help our production team and our engineering team to manage all the activities necessary in our production line. So here I'd like to share a video about the Smart activities, just to give you a better vision about our production and how we can work and how we manufacture our product. The video is around 3.5 minutes, but I think that it's important to give you a better understanding from our activities in Brazil.
Each new day, technology is more and more present in people's lives. Everyone is more and more connected. Technology does not stop evolving, advancing. Smart modular technologies is at the very heart of all this evolution, developing and innovating in the semiconductor industry. With a large and modern production center, advanced equipment, high-tech, high-precision tooling, machine-to-machine communication, robots, training and advanced manufacturing, prepared for the fourth industrial revolution. Industry 4.0. Smart delivers products that form a tripod, processing and storage, communication, energy. More than 15 years producing semiconductor components for the world's largest manufacturers and dominating the chip packaging technology in Brazil. Memory modules at the forefront of high performance. Lithium-ion polymer batteries provide power to the most renowned devices in the mobile communications market. Approximately 670 million reais were invested in the development, design, and implementation of semiconductor components, such as memories for smartphones and other high-tech memory integrated circuits. And additional investment that can reach 700 million reais by 2021 is already planned. Smart is a global company and is proud to have chosen Brazil to be its technology center for semiconductor components packaging. Strategically located in the city of Atibaia, state of São Paulo. Smart also has a research and development center dedicated to its operations in South Korea. Products with high standards and excellence. 250 million reais have already been invested in research, development, and innovation of products and manufacturing processes. An example of this is the unprecedented investment in the creation of a semiconductor prototyping line within the El Dorado Research Institute in Campinas, state of São Paulo. The worldwide technological evolution does not stop. The priorities for the Internet of Things are already defined in Brazil. Smart is part of the National Internet of Things plan, developing innovations to keep at the forefront of all this evolution. People recognition, training, and specialization. Professionals with the highest levels of academic background. The challenge of further driving and developing semiconductor technology is the challenge of creating the future. Smart works unceasingly to be at the front line of this future. Think memory, think smart. Smart modular technologies, developing technology and projecting the future in Brazil.
So this is the video that I'd like to share with you. So this is important to give you a better understand what kind of capability we have inside of Smart and what we can do in our production. So moving ahead with our presentation. So here I'm showing the main activities that we have considering the R&D team that we have in Brazil and Korea. As I already said, we have a very close relationship with a development team in Korea. We have more than 30 engineers located in Korea to support our activities in Brazil. So basically, we are focused on to develop a new business, looking for the market necessity, designing new products. So also we have a very close relationship with some universities in Korea, where we can send our engineers to Korea to join some trainings, to learn new technologies, new products, and once they are prepared, they come back to Brazil and help us to develop the products that is important for us. So besides of Eldorado, Smart already have several relationship, a very technological contract with some universities and also some institutions located in Brazil. So not just for Eldorado, but we already we have projects with some universities in North and Northeast Brazil. Also, we have some projects on development with South area in Brazil. So we have several projects with some universities and institutions that can help us and support our internal activities. So just to give you one idea about the advanced package lab that we have with Eldorado in Campinas. So we have one structure that is already prepared to support our development for any kind of technology, for any kind of semiconductor device. So we have a high-tech die preparation, also inline equipment, and also for back-end to support any kind of activities that we need to do. Talking about some capabilities, the technical capabilities that we have. So nowadays we are able to develop some products designed in Brazil. So some system in package, we just concluded one product that we developed recently, is a system in package based on a LoRaWAN technology. I will talk about a little bit more with this development that we did later on this presentation. Also, we are able to develop some integrated circuit packaging process. So we are able to develop a new process assembly inside of Eldorado. So we can also validate some multi-chip package once you are talking about the new technology. We are able to do some memory model designs in Brazil. We can support this kind of activities. And also we are able, now we are working on IoT product design. We already developed some modules, some evaluation boards, and some application boards that we are supporting the market necessity and some customers that we have nowadays inside of Brazil. Also, we are able to test and validate some new technology. So at this moment, we are studying and evaluating two new technology that we imagine that is very important for us, looking for 5G technology. One of them is the laser trench. The laser trench is a process that we need. We have a picture here, right? So we need to make a small cut on the device, and in a sequence, we will provide a EMI shielding. Is an electromagnetic enclausuration to support the IC once we are talking about the telecommunication process, especially for 5G. Once we are talking about the technical manufacturing process, we are able to do several activities. We are able to prepare wafers up to 30 micrometer thickness, are very thin wafers that we can use in our encapsulation process, on the package process. We have also the static dicing before grinding, is a new technology to prepare the wafers to be used on the inline process. We already developed some products that is able to have die attach up to 16 die stack. So we have a picture here where let me use the laser point. So this is a product that we developed inside of Eldorado, where we have 16 die stacks, and also we transfer this technology for our manufacturing process. The most complex device that we have nowadays is we have 11 die stacking. inside of the same package, and the thickness of this package is around 1 millimeter. So then you can imagine how complex and what kind of challenge that we have to assemble this product in our production line. And also to give one idea, the substrate thickness that we are using nowadays in our product is less than 0.1 millimeters. So we have a very, very close relationship with Samsung. So Samsung is our strategic technological partnership. So they are responsible to support us with the wafer level. So all the wafers that we use in our production came from Samsung from Korea. Just to give you one overview, one idea how much certifications and compliance that we have inside of Smart. So he's a part of all of them, a part of the certifications that we have. I'd like to call your attention, especially for the ESG factors or the ESG principles that we have nowadays. We just implemented, and our first sustainable report was launched last month. So we can find this report in the internet, in the LinkedIn. We can find this report from Smart, where Smart Brazil is located inside of the Smart Global Holds report. Also, I'd like to call your attention about the AEO certification that we already have. And as Smart is a NASDAQ listed, we need to follow the SOX compliance, and we suffer annual compliance audit to be according the governance and the regulation and the compliance that is necessary for NASDAQ regulation. Also, we are RBA is a certification since 2013. And also it's important to point out that we have a lot of certification from our major OEM suppliers in Brazil. Here is our manufacturing model, the way that Smart used to work in our production line. So we started our production once we receive the wafers from Samsung. Then we have all the IC package line, all the package assembly and test. 100% of our devices is tested in our structure. And part of them we can provide directly for our customers. So our main customers is Samsung, Lenovo, Dell, HP, and the others. So, and part of the IC that we assembled, we are assembling our IC package. Part of them is transferred for our module assembly line inside of the other company. So the IC package, the IC is our raw material to assemble the modules and the other devices, especially memory modules and SSD. Once we conclude the process assembly, these products will be provided for the customers as the same of the IC package. Just to give you one overview about our product portfolio, this is what we have nowadays that we can provide for our customers, especially in Brazil. 100% of our production is just to support the local market. So nowadays we don't have an exportation process for Smart. All the devices is to cover our necessity in the local market. Sorry. So this just to give you one idea. So where our products can be used. So we have on the left side, we have all the products portfolio that we have. And from the top side of the slide, we have the applications. And also you can take a look and see where our products can be used in the products that we have in the market. So let's start to talk about the IoT development activities that we are doing inside of Smart Brazil nowadays. So we started the activities for IoT around 3 or 4 years ago. And on that first moment, we decided to take a look on the IoT wireless connectivity technology that we have on the market. So we started to make one study about the value chain and try to see what is the main technologies that we have for this kind of products in Brazil. So based on several research that we did with some partners and potential customers, we identified that the most relevant and most important activities that we need to put focus is on long-range technology and especially on low power one. So then we start to study what kind of technology we have inside of this group. So then we identify LoRaWAN technology, Sigfox, and also LTE, CAT-M, and CAT narrowband activities. So once we have this definition, we prepare our strategic plan inside of Smart to start our internal development. As the second part, once we identify the technology, so we start to study the market necessity and we start to identify what is the potential device that we could work, considering the technology that we imagine that is interesting to support our internal activities. So then we decide to work especially on the base. We start to work using the device to support especially access manage, street lighting, water metering. So then we start to put and work internally to develop product to support this our internal necessity. Here is the main application segments that we defined as inside of our strategic plan. And at this moment, we are putting focus especially in metering segment and also for tracking segment. All the products that we are developing nowadays and also the products that we already developed is to support the activities on these segments. So we are putting focus on power, water, and gas. And also we are putting focus especially on asset trackings. Based on these, all these definitions, we started to develop our products in the Brazilian, inside of the team. So the first product that we launched is the LoRa Primo, is this device. It was launched in May 2020. Right, and in a sequence, we started to work in other different products with the same footprint and with the same technology. What is the advantage, right? So why we defined to do the same footprint? So this is one advantage, especially for the customer, for the final customers, because once they develop a product using our module, is it possible to change the technology very quickly and they don't need to change anything on their design. So the main idea here is to give the flexibility for the customer to use different technology in the same PCB design or in the same product design. So also we are working in other products, we are developing our other modules. So nowadays we are developing a Sigfox module. So our intention is to release this product in the first quarter from calendar year 2022. And for the calendar year 22, we also we have a plan to launch our NB-IoT module in partnership with Qualcomm in Brazil. So once we start to develop our products, our module, we identify that we need to move ahead. We need to give one step forward in the development. So then we decided to develop some application boards to support the activities in Brazil. So in this case, we launched in August 2 application boards that I can give you more detail in the next slides. So this is our first module that we launched in May 2020. So we already have around 60,000 devices in the market under usage in different applications. And up to now, we didn't receive any return from the field. One thing that is important to say about our module, 100% of the devices that we are manufacturing in our company in Atibaia is 100% of them is tested in the production line. So we have a high confidence that the product have the right quality to support the activities in the market. Additionally, one additional information that is important to say, our module is able to work with up to 20 GPM RF power transmission, and we have 6 GPIO communication on this device. So to support the activities from our customers, we decided to develop one evaluation board. So this is a board that we can provide for anybody that they wants to test and validate our product. So if you want this board, just get in contact with our new business development, so I can give you the details later on. But you can request this board and you can use this board to test and validate and see how our product is working nowadays. So also we have a very good technical team inside of Smart that can give you the total support to develop your product. We can provide also some reference design that we have available. And the main idea here is to reduce, and we can have a small time to prepare your prototypes. This is another item that we are working with our local team. So we implemented a application oriented at AT commands. What does it mean? So we developed some commands inside of our firmware that we are putting inside of the device that can provide or can give you the possibility to implement small application very quickly. So you don't need to develop the firmware since the beginning. So you can provide just some AT commands to the device, and you can configure the device to work as you want. For example, we have the firmware already prepared for signalization button, a temperature measurement, and also can be a system control. Here, just one overview about one of the application boards that we have. So it is a very small device. It is like an emergency call button. So we have one accelerometer inside of this device. So if you found out, we can send some message for the servers, or also you can configure some mobile device to receive the message. So it can give you some support and call your attention based on the emergency situation that we can have. So this board is already developed, and we are able to support with prototypes, with samples to validate and see how the device is working. So here also is a track device. So we developed this one very small. So we can put this device inside of a cigarette package. It is smaller than a cigarette package. So we can use this device in different applications. So we can use as a tracker. We can use as a emergency. We can use to monitor some items like children and other application as well. As you can see here, so this is some field tests that we did. So we provide some samples from some people inside of the team, and we start to monitor their location during a long period. And here is what we are showing is the tracking device working in two different scenarios. So the idea here is just to give you one idea how our device can work and how they can provide the information to you. So that's I'm going for the end of the presentation, but I'd like to give you some idea about the new product that Smart is working. Is a local development that we are doing in Brazil. So our team started to work in a system in package design. 100% of the device made by the team in Brazil. And the idea is to reduce and put all the functionality from a LoRa device in one integrated circuit. This is some pictures from the design that we did, from the activities that our team handled in Brazil. And here, what we have inside of this device, we have a die from a partner that we make one agreement with them to provide the wafers to us. Also, we have one RF key and also one accelerometer inside of the same package. So in other words, we can have the LoRa module, the same one that I already showed in the previous slide, in one device, one small device. So based on that, we can reduce the size of the final product, and based on this, our intention is to increase our capability and have a better performance compared to the previous module that we developed. So just to give some image about the device. So we already conclude the prototype assembly 2 weeks ago, and what we can say is, considering the test that we did up to now, the device is working based on the specification that we did. So here is a picture from the device. So the final is a LGA type, and the size of this device is 11 millimeters by 7.5 millimeters. So here is the structure, the package before the molding process, and here you can see what we already developed and what we already did. As the next steps, what we want to do, we are starting to do some internal qualification. We are trying to use the device, putting in different applications and try to see his behavior once we start to work with this device. Additionally, we are working to develop some evaluation boards. The main idea that we have in mind is to provide this device for some tests using some customers that we have in our portfolio. So just to conclude my presentation, this is my last slide. So Smart recently launched some media communications in Brazil. So we have one specific web page for the activities that we are doing in Brazil. So you can find more information about our product, our activities. Also, we are preparing some case of studies about the performance from our devices. So we would like to share more information about our internal activities with the community, and the way that we are using to promote this kind of communication is the website from Smart Brazil and also from the LEKG. So thank you very much for the opportunity. This is all I have. I hope to cover all the expectations during this presentation.
So thank you very much, Cleber. It was a very nice presentation. So we can have a nice idea about the activities of Smart. So for the audience, if you have any question, please do it as soon as possible by writing it in the YouTube channel. But waiting for questions, I have one. So I received the wafer. So can you say from which foundries which kind of technologies you got wafers from?
So in fact, we are buying the wafers from Samsung Semiconductor Inc. in South Korea. So we bought the wafers from them, and we are receiving the wafers directly. Considering the technologies that we have for flash IC, we have 14 nanometers technology, the node that we have. Once you are talking about LPDRAM, we have 18 nanometers from node. So depends on the wafer, what kind of wafer, and also the technology that we have. Because for flash we have VNAND, we have a planar technology also once we are build the wafer. So depends on the technology to manufacture the wafer. We also have a different technology once you are talking about the node.
Okay. So which is the process you use to cut the wafers?
So at Smart Brazil, we have several different process to cut the wafers. So the most or the highest technology that we have nowadays inside of Smart is SGBG. So I showed in one of my slides this technology. So what we did, we have a laser that we can break the crystal arrangement in the middle of the wafer. So then once we have the expansion process, we have the cutting. So then we can have the individualization process. Then we can have the die to be used on our process assembly. Beside of that, we have a laser grooving is another process that we have. So we removed the metal from the switch, and as a second step, we have the blade cutting process. So we can cut using a blade, very how can I say, very slow process to avoid to break the wafer during the process preparation.
So this blade is made with which material? Huh?
Diamond.
Diamond. Yes.
Yes.
Okay.
Yes. This is and also we need to use water. So this is one of those resources that we use in our production line. That is very important to us is the water, because most of the process that we have, back grinding, the singularization process, we have several steps in our production that is necessary to use GI water. So, and our consumption in water is very, very high. This is why we also have a reusage process. So we can reuse our water around 80% of the total quantity that we are using nowadays inside of the company. We can use 3 times in the process. We have one treatment inside of Smart, is specific for our company to treat the water to reuse in our process.
Okay. So another question by myself is that you show about the process where you have till 16 tiers or 16 dies, one of the other. So
Yes.
how you do the connections between these chips?
So this is the technology that we are using to make the connection in all these 16 die stacking, Professor, is a wire bond process. We are using a wire bond. However, we need to take care, right? Because as we have how can I say, we have like a skate, right? So we have several dies put one above the others. But to make the connection, we need to take care about to don't have the gold water in contact with the above die. If I have this one, I will have a short on the die and I will lost the device. So you can imagine we can have a very thin device with a 30 micrometer thickness, and also we need to take care about the wire bond to avoid the contact with the die that we have above. This is the most complex device, and this is the challenging device that we have to assemble in our production line.
Have you any plans to also do 3D chips using TSV through silicon vias between the chips, between the tiers?
This is one technology that we already started to study. In fact, we had one agreement with a university in Korea some years ago, and we selected 3 or 4 engineers from Smart to travel to Korea, and the guys stayed there around 1 year just to study and learning the TSV process to be implemented in Brazil once we have any product. So we have these guys with the knowledge, and this is one technology that we are looking for our future product. It is on our technological roadmap.
Yes, nice. So this is one of the futures that is arriving.
Yes.
And
The biggest challenge on this process is how the wafer can be manufactured, right? Because we need to have some drills on the wafers. We make to how to make the connection between one wafer and the next one once we put one above to the others, right? So this is the main challenge that we have on this process.
Okay. By the way, we had planned to do a seasonal school on 3D monolithic 3D circuits. Then it was postponed due to the COVID, but maybe next year. So if you do it, we are going to announce as early as possible. So there is here a question by Giselle Assunção. Do you grind thin the whole wafer and then split it into dies, or are the individual dies thinned?
No, we receive the whole wafer and we make the grinding in the entire wafer at the same time. So we received the wafer with above of 200 microns of thickness, also above this one. Some products we received with more than 400 microns of thickness. And we use the grinding process to reduce the die, the wafer thickness. Then we can make the second step, right? So it depends on the technology. So if we are talking about the back grind, the SGBG, the process is a little bit different. But if we are talking about the grinding, and then we have the laser groove and the die sawing process, so we need to reduce the thickness for the whole wafer before we cut to have the device for the die attach process.
Okay. So I see no more question here for the moment, but I have another one. So one trend is to put all the electronic in just one chip. So how you see this evolution of this trend?
Yes, this is the project that the last item that I presented is about the system in package, right? So the main idea is to put all the devices in the same structure, to support the activities. So from my point of view, this is the tendency that we have for the future. So the main idea is to reduce the devices that we have in the market. However, we have a lot of challenges on this process, as I can see, right? So we need to take care about the timing, the communication timing between the device that we have, because the package is very small. So, and how we can put all of them in the same package because we will have all of them very close to each other. Then we can start to have other problems like crosstalking. We can have electromagnetic interference between one to the others. So we have a lot of time on this process, Professor. But from my point of view, this is the tendency, and we need to be prepared on this process. And the future is coming, right? So the future is coming, and the technology is showing to us that we need to be prepared for this, and Brazil needs to have this internal capability. And we need to work together with the university and the institutions that we have in Brazil and abroad to see what we can improve and how we can work with this new technology. This is my perspective from the once we have the reduction for these devices.
Yeah, but to solve some of the problems that you reported, so one trend is to put all the electronic just in one chip.
Yes.
So not several chips in one package. That is also an important step, no? But to do everything and the 3D chips, the ones with TSV and the ones also that are monolithic, is also a possibility to have chips with different process technology dedicated to different types of circuits and put everything in just one chip. So do you agree with this?
Yes, I agree with you. I think that this is what we need to look for. And the process is how we can connect the dice, right? Once we have different technology in the same package, how we can work with this technology, put everybody in the same package. The connection is very important as well, right? So because we have different technology, as we already discussed it. So we have wire bond process, we have flip chip technology. Also, we have TSV. So we need to use this technology to support. And from my point of view, this is the tendency to have all the devices in the same package. So if we take a look inside of a smartphone, we can see that we have just one or two chips, the biggest chips that we are concentrating all the technology in the same device. This is the future.
Yeah. Okay, so I see no more question, but about 3D chips also, I invite all you also to see there is some few talks in the CAS talks that are available in this YouTube channel. One is by Professor Małgorzata Jeski from Portland, USA. That is dedicated to 3D chips also. So thank you very much, Cleber. It was a very nice presentation, very interesting to see what Smart is doing. So it's great to have a company like Smart here in Brazil. And so I wish you in this success and to be improving more and more. And so thank you very much for your nice presentation. So now I'll just remember you of next activities we are programming. So next Friday, we have a talk by Roberta Burger from Infinium, Germany. So this will be the last CAS talk of season 2021. And she's going to talk about challenge in pre-silicon verification of analog mixed signal for automotive products. So I hope that all you will come back to this YouTube channel to attend the talk next Friday. Then We expect to restart the CAS Talk in season 2022 by February. We have already some talks that are already scheduled for March and so on. So, and then in December 13, 14, we have the YCAS and the IEEE CAS Rio Grande do Sul meeting. Soon you are going to see the program. And if you lost the talks, CAS talks and industrial talks last year and this year, you can find the recorded sessions at this YouTube channel, as well some talks from Microelectronics School, DPVSA, Seasonal School, and others. So there is more than 100 talks there now. So thank you very much again, Cleber. I wish all you a nice rest of the day, a nice afternoon, or nice evening, or nice morning, depending where you are. And see you all next Friday, same time, 1:30 p.m. Brasilia time, GMT -3. So bye-bye.
Thank you very much, Professor Ricardo, for the opportunity. It is a pleasure for me to be a part of this, and I hope to cover all the expectations from the audience. Also, I'd like to give my linkage. So it is the same of my name that you are showing in the presentation. Is Cleber Figueira. So if someone wants to get in contact with me to get more information about our product or about the activities that we are doing inside of Smart Brazil, will be a pleasure to support and answer the questions that we have in our mind. Thank you very much again, Professor. Thank you.
Thank you, Cleber, for your nice talk. So bye-bye to everybody.